Many people may already know this, but from an engineer's perspective, if you ask what Arduino is, it's common for someone to simply say, "Isn't that just an AVR board?" In fact, since Arduino boards started with AVR boards, it is true that a significant portion of Arduino boards are indeed based on AVR. However, Arduino is not solely made up of AVR boards. It can actually be described as a type of hardware platform. In this session, moving away from overly educational or theoretical content, I will explain with the assumption that those watching this video are engineers. As you all know, the hardware market has a significant number of vendors and a wide variety of processors. For vendors, we have ST, TI, Atmel, and for processors, there are 8-bit MTUs, as well as high-performance 32-bit processors from ARM. However, when trying to control the desired operation in hardware, for each vendor and processor, there are similarities, but the commands are slightly different. So, if I am currently working on some hardware with the SJ8 and then want to create something using a TI-related hardware MCU, I have to study and develop according to the commands, pin maps, and registers that they specify. This can be quite cumbersome, which is why the term Arduino compatibility is used. So, if we say that everything is Arduino compatible, we have GPIO available, whether it's from ST, TI, or any 8-bit or 32-bit ARM processor. We can control all of these with the same commands. Here, I have a simple example, setting the pin mode for D8 as output and using digital write to turn it on and off digitally. This means that if it's Arduino compatible, we can control it with the same commands, regardless of the vendor or processor. Of course, it's not possible to control everything 100% compatibly, but for general cases, it is quite convenient. Moreover, it's not just the software and firmware that are compatible. The hardware is also compatible. For instance, even if it's the same vendor's MCU, the pin maps can vary slightly between different MCU parts or series. However, if it's Arduino compatible, the pin map will be adjusted to fit the Arduino compatibility. If you look at it now, this is the Arduino Uno. It is the most representative and very well-known Arduino board that uses an Atmel MCU based on AVR. If you look at the pin map, you can clearly see that there are digital pins at the top and power pins along with analog input pins at the bottom. They have established a clear guideline for this, so we can think of it as an accessory called an Arduino Shield, which is designed to fit this pin map. For example, the Arduino Uno is just an 8-bit microcontroller without any internet-based communication features. However, if I want to add internet-related functionality, I can plug an internet accessory, the Arduino Shield, on top of it, which will enable internet capabilities. Since the pin map is standardized in this manner, accessories can therefore be compatible and fit accordingly. In the past, if you wanted to connect Wi-Fi or sensors to a microcontroller, you would need to know that this is I2C and so on. You need to consider which pin to connect to for I2C, and if it's UART, you have to connect to TX and RX. However, if the pin map fits perfectly, you won't have to worry about that and can just plug it in. Of course, if you are a true professional engineer, you should be able to connect everything without such considerations. But when you want to work quickly, the compatibility allows you to simply plug in an Arduino compatible shield without worrying about anything else. it will automatically connect to the necessary pin map and interface ports. So, when asked about the advantages of Arduino, I personally believe it is rapid prototyping. For example, if you want to create a fine dust measuring device, would you immediately start designing and manufacturing the PCB? Of course, there are cases like that, especially if it's a large corporation. But realistically, many people find it quite difficult because it is closely related to money. For instance, if you immediately start production after designing a PC, actually creating a proper PC could cost around $200 to $300, which is not something you can do carelessly. However, instead of that, you create a prototype in advance. For example, if we assume we are making a fine dust measuring device, I would first select a fine dust sensor suitable for the product. Then, I would check if there is an Arduino compatible fine dust sensor shield or breakout board available and secure it. Once that is secured, I would also ensure that there is a corresponding sensor library for Arduino. At that point, I would simply plug the sensor into the Arduino, run the library, and immediately test it to see if it functions as the desired product. This is how you can create a very fast prototype, and I believe this is one of the strengths of Arduino. However, what are the weaknesses of Arduino? Honestly, the prototype stage is quite good in my honest and personal opinion. However, I think mass production is a bit challenging. As I mentioned earlier, Arduino is compatible with various processors, whether they are from the ST family, TI family, or others. But when it comes to prototyping, the most commonly used platform is the Arduino Uno based on Atmel, because there is a lot of documentation and resources that are available for it. However, just because I created a prototype using an Atmel-based Arduino doesn't mean my final product will also be based on Atmel. To be completely frank, Atmel-based MCUs tend to be more expensive compared to competitors. So, if it were up to me, I would quickly develop and verify the prototype of the product using Arduino, and then focus on achieving cost effectiveness and supply, especially considering the current semiconductor crisis, which makes sourcing components quite cumbersome and meeting desired price points challenging. We select an MCU that meets the product features with good cost effectiveness and no supply issues. Then, instead of immediately creating a PCB, we purchase a development kit that uses the selected MCU, meaning we buy development kits that include that MCU or similar series MCUs from the vendors. This way, we first buy the development kit and then develop the firmware, testing and verifying its operation. If everything works fine, we proceed to PCB design. After completing the PCB design, instead of immediately saying, I have completed the PCB design and the artwork is done, we first create sample PCBs. We produce about 6 or 7 sample PCBs, or just 2 or 3 to validate the board. If there are no issues, we then move on to mass production. This process shows that while Arduino is very strong for prototyping, it has limitations for mass production. So it would be better for you to optimize the process for mass production. Additionally, when working with Arduino, there are many things to consider. In general, when it comes to sensors, voltage is crucial for communication. Therefore, whether it's 5 volts or 3.3 volts is important. Of course, you can use a level converter to communicate with a 3.3 volt sensor even if you only have a 5 volt Arduino. However, this can be quite cumbersome. So, if I explain based on the 5 volt standard, when working on projects or prototypes that use 5 volt based sensors or communication, the best selling option is the Arduino Uno. However, the downside of the Arduino Uno is that it has limited GPIO pins and, relatively small memory, which can be frustrating for those working on heavier projects. So, for those individuals, there is the Arduino Mega 2560, which is a slightly higher performance, 5-volt Arduino board that you can use for development. You can develop with this board. And if you need an Arduino that operates at 3.3 volts, you can use the Arduino Do. By the way, the Do has a very powerful processor since it is ARM-based, so it can handle most heavy tasks quite well. In addition to this, there are a lot of Arduinos, but I only explained the most representative ones. So, in the future, I will cover the basics related to this Arduino series, but it won't be just for beginners. I plan to explain things that engineers need to know, what is necessary when creating actual products, and the essentials related to development. First of all, I need to explain the part related to GPIO control, as well as interface control, including SPI, I2C, and UART control. I will also explain how to create a live project, and various other topics. Additionally, if there is anything you would like to learn about Arduino, please leave a comment and I will take a look and create a lecture on that. In this session, I briefly explained what Arduino is. To be honest, it contained a lot of my personal opinions. Also, I don't plan to focus solely on this Arduino series. If you suggest that you'd like to have lectures on various microcontrollers like Raspberry Pi or ESP32, I will prepare those as well and work on another series. So I'll see you next time.